Hello guys, let's learn about solid principles in LED. At first, think of a building. If any one of the room catches, does the whole house collapse? No, right? So programming is the same. When we want to build an application, we need our code base in such a way that we can easily change and easy to fix and easy to extend and easy to test and easy to understand. We need to write our code backend code base in that format. So solid is simply 5 rules that helps us to write code like that. So S stands for single responsibility principle, and O stands for open close principle, and L stands for least cost substitution principle, I stands for interface segregation principle, D stands for dependency inversion principle. Now don't memorize them yet. One evolved due to the mistakes made by the programmers on the previous version. Like, remember this sentence. What I meant to say is each principle exists because programmers kept making one common mistake. Okay, so instead of learning direct definitions, formal definitions and examples, let's first learn what was the mistake they made. Okay. Imagine we are building an Amazon backend database. So usually we have user, product, cart, payment, email database, etc., right? So now here comes the single responsibility principle. Okay, so single responsibility principle, let me take an bad code example. Now now what is the class doing? So the class is doing everything like login, logout, database, email, sending email, generating reports, etc., right? It is doing single class is doing many everything. Okay, so imagine one day your boss comes and says the change the email system. Now you are opening the user class again and you are making some changes in the email system. Then tomorrow your boss comes and again he says to change the database. Then again you are opening the user class and making some changes in the database. And next day the boss asks to change the report format. Again you are opening this user class and making some changes in the reports format. So the user class changes every week. That's dangerous because whenever we make some changes, right, these, like suppose we are changing the format of reports, and this code is already being tested and it's live in the production. Okay, whenever we change the reports format, these might have effect on these class and methods also. So it's a bit risky. So what we need to do is we need to separate out each method to its corresponding class. like user related activities will be in the user class, and database related activities will be in the repository layer, and some additional services will be in the service layer. So they are separated into the service class, repository class, etc. Now what SRP says, a class should have only one reason to change, not one method, not one function, only one responsibility. So if I think of class user, then my user class is only responsible for login, logout. Okay. Now let me split this. So user repository, in the user repository usually I'll be having this thing. So how I'll be splitting out this is, let me create a user repository, and inside this I'll be having save to database. Whatever data I receive, I'll be saving that data to the database. And now this will be in the email service. As email service. And this will be the report service. As reports service. And this will be, yeah, this is already done, right? So now if you see here, login and logout are also related to the user repository things. Like they are testing out login user is valid or invalid. So I can add some logic here, like hashing the password and everything, etc. If you see this code now, this is a bit readable, like each service and each repository layer has its individual functionality and methods. So whenever I want to have some changes like database changes, I'll directly go to the user repository and if I want to add some additional email thing like adding new email service, then I'll directly go to this email service. In that way they are isolated and they won't affect the existing classes. So let me give an easy memory trick. This is much cleaner now, right? Let me give an real life example. Suppose a restaurant has a single chef. So now that chef should should do. Suppose a restaurant has a chef, okay? So should that chef cook, wash dishes, and delivery food, collect payment? Should all of this work should only that single chef do? No, right? Each person should have their individual job. So same with the classes. My class user repository has its own methods and its own job, and the email service has its own methods, its own job. So this is the thing what SRP helps us to understand. Like each class should have its own responsibility and should have its own job. That's it. Let's learn about open close principle in the next video.